We're carrying on with indicators now. So these are the red and blue litmus papers. Obviously these are the blue litmus papers, these are the red litmus papers. I'm going to leave one to show you what they look like normally. So that's blue litmus, that's red litmus. Even though it's a pinky colour, it's called red litmus paper. And to each one, I'm going to put acid first. So acid on the blue litmus paper and acid on the red litmus paper. And you can see that the blue litmus paper turns red, the red litmus paper stays red. Next, water onto the blue litmus paper and the red litmus paper. Blue litmus paper stays blue, red litmus paper stays red. And finally the alkali onto the blue litmus paper and the red litmus paper. The blue litmus paper stays blue, the red litmus paper turns blue. Now on the next page of your booklet you've got the pH scale. This is the pH scale. It goes from pH 1 all the way to pH 14. So pH 1 is a strong acid going towards weak acids at 5 and 6. Neutral is 7, pH 7, and then we go on to weak alkalis and strong alkalis. Now universal indicator shows us a range of colours. That's why it's very useful. It changes colour depending on the strength of the acid or the alkali. Very few indicators actually do that. So universal indicator is a better indicator because it shows you the strength of acids and alkalis. As well as that, rather than relying on a colour change, because sometimes they can be very subtle, looking at those two tubes now, they're very subtle differences, you can use something called a pH probe. It doesn't necessarily look like this. It can be more oblong, it can be different shapes, but all it's got is a digital display, and you push the probe into a liquid and the digital display reads on the display. So you put it into the liquid and it reads whatever pH number you're getting, and it goes to 2 decimal places. So this can be much more precise rather than relying on a colour change.